Lesson 2.6, Proving Angles Congruent. So in this lesson, we're going to start bringing in and kind of introducing what a proof is. Alright, so you can use given information, definitions, properties, postulates, and previously proven theorems as reasons in a proof. So when we do a proof, you're going to have there's going to be given information, there's going to be what you're trying to prove. So we're going to use that given information. We're going to use definitions that we've used this year, like midpoint or bisector or segment bisector. Properties we've learned, postulates that we've gone over, and then any previously proven theorems as a reason to prove. So the theorem is a conjecture or statement that you prove true. So these conditional statements, we're going to use those and prove those to be true. And we're going to use all these different ways to do that. So before we go there, let's take a look here. These are some of the properties of equality that we've talked about. A lot of these you've heard before in middle school. The first one is addition property. So if A equals B, then A plus C is going to be equal to B plus C. So if you're adding the same thing to an equal value, then they're going to be the same. Same thing with the subtraction property. If you take away C, take away B, and A and B are equal, then it's going to be the same value, same result. The multiplication property, A times C is equal to B times C if A is equal to B. Division property is a little different. If A is equal to B and C cannot be 0, then A divided by C is going to equal B divided by C. If you're dividing the same number by the same thing, it's going to be equal. The reflexive property, where this is one we're going to use a lot, these highlighted ones. The reflexive property is where A is equal to A. Okay, where something is equal to itself. That's called the reflexive property. Symmetric property is if B is equal to A, then A is equal to B, then B is equal to A. It's like a mirror image. It's symmetrical. Transitive property says that if we have A is equal to B and B is equal to C, then we can say that A is equal to C. So if you have two equations that are equal to the same value, then you can set those two equations equal to each other because by the transitive property. And the last one is substitution. If A is equal to B, then B can be replaced anywhere there's an A in that expression. That's called the substitution. So when you solved equations, system of equations by using substitution, this is what you did. You substituted an equal value in place of another variable. So let's take a look here. Vertical angles theorem. Vertical angles are congruent. So we've talked about this a little bit in chapter 1. Okay, if 1 and 3 are vertical angles, they're formed by intersecting lines, they are congruent, and 2 is congruent to 4. When you're writing a geometric proof, it may help to separate the theorem that you want to prove into a hypothesis and conclusion, which we call that a conditional statement. Another way to write the vertical angles theorem is if two angles are vertical, then they are congruent. The conditional. If this is happening, if two angles are vertical, then they are congruent. The hypothesis becomes the given statement, and the conditional conclusion becomes what we're trying to prove. We're trying to prove that they are congruent. A two-column proof can be used to prove the vertical angles theorem, and that's the type of proof that we're going to use the most in this class. So here's our proof. Angles 1 and 3 are vertical angles. That's given information. We can remember we don't have to have any other markings on here. We can see that these are vertical. Angle 1 is congruent to angle 3. We're trying to prove that to be true. So let's take a look here at our proof. In a two-column proof, you have statements. These are things that you know. And then you have reasons. And this is going to be where you're telling me how you know this is true. So 1 and 3 are vertical angles. Well, anytime that's appear in the given part, what we do is we write this is given to us. So we write given. That's how we know it's true. They told us. 1 and 2 are supplementary angles. So 1 and 2 are supplementary angles. And 2 and 3 are supplementary angles. Okay? So this is where we're going to go back to a definition. So angles that form a linear pair our supplementary. Okay, so 1 and 2 is supplementary, and 2 and 3 are supplementary because they form a linear pair. So the measure of angle 1 plus the measure of angle 2 is equal to 180. Okay, 1 plus 2 and 2 plus 3. Okay, so the reason for this is the sum of the measures of supplementary angles equal 180. So the sum of supplementary angles is 180 degrees. Okay. Now let's look at this. If the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Okay. So if they're both, if you look right here, measure of angle 1 plus 3, okay. So if you add 2 to these, then they're equal to each other. Okay? Because what we're saying is that if 1 plus 2 equals 180 and 2 plus 3 equals 180, then we can say that these two equations are equal. And that's the transitive property of equality. Okay? We kind of talked about that on the last page. So if 1 and 2 is equal to 180 and 2 and 3, these two expressions are equal to the same number, then what we can do is we can just say that these are equal because they're both equal to 180. So we can say this is called the transitive property of equality. So when you're working a proof, it's no different than me asking you a question, you tell me how you know it's true. You're just going to write it out in written form. So now, let's take a look at the next one. Okay, angle 1 is equal to angle 3. So what we've done here is we've taken away the 2. Okay, because if you were to bring this over here, whatever this number is, let's say it's 30 degrees, this would be 30 degrees. Well, I subtract 30 from this side, it cancels out. So that cancels out by the subtraction property. And then the last one. If the measure of angle 1 is equal to the measure of angle 3, and their measures are equal, then we say that they are congruent. So we say angle 1 is congruent to angle 3. And the reason why is, well, angles with the same measure are congruent. Now at any time you can always use symbols in here to represent. So we could put a congruent symbol here, we could put equal here, but you can see how I use the angle symbol here. So what we did is to show that these were equal, we showed that they're supplementary. And then by the transitive property, we said that these were equal, two equations are equal. Then by the subtraction property, we can show that you take away angle 2, and that means that these two have to be equal. Alright, so this is just kind of the first introduction of a proof. We'll do a lot more proofs in chapter 4. So let's take a look at this. Assuming that we understand what the vertical angles are congruent, what is the value of x? Well, if I look at a problem like this, I see two vertical angles, then I should know that these two are equal. This angle and this angle are equal to each other. So to set it up, we're going to say that 3x is equal to 2x plus 40. Now it's a matter of solving for x. So I'm going to subtract 2x. X is equal to 40. Very quick and easy. Okay. Had they asked what the angle was, you plug it back in, and this angle would be 3 times 40, which is 120. Okay. That's going to be 80. 80 plus 40 is 120. So you can just double check to show that they are correct. So find the measure of x for part B. Pause the video, come back and finish it when you're done. All right, these two are equations are going to be equal to each other because they're vertical angles. Set them equal, solve for x. So I'm going to bring the 2x to the 3x. I'm going to bring the 10 to the 42. If I'm subtracting here, I'm adding it over here, and that gives me 52 is equal to x. Now you can always plug this back in and get your result, but all they're looking for here is the value of x. So your answer would be 52, and then the first one was 40. So let's fill in this proof. So we know that angle 1 is congruent to angle 4. They told us that. Okay? And so we're trying to prove that angle 2 is congruent to angle 3. Well, 1 is congruent to 4, and that's given. The second one, it says 2 is congruent to 4. Well, how is that possible? Well, how do we know 2 is congruent to 4? What type of angles are they? Well, they are vertical angles. So we know vertical angles are congruent. So we can say vertical angles are congruent. Okay, vertical angles are congruent. So we know that these two are now equal to each other, are congruent. That means that 1 and 3 should also be. So now it tells us that 1 is congruent to 2. Okay, so since these two are congruent, the same, then these two must be congruent as well. So 1 is congruent to 2. That's by the transitive property of congruence. It wasn't equality because it's not equal sign, it's going to be congruence. And then 4, it says vertical angles are congruent. So we're missing a vertical angle. What other vertical angle have we not written down? And that's going to be angle 1 is congruent to angle 3. Those are the other vertical angle. We said 2 and 4. Now we're doing 1 and 3. So vertical angles are congruent. So now angle 2 is congruent to angle 3. Okay. And the reason is going to be the transitive property of congruence. The same thing right here. Same thing as we substituted in. Okay. If these two are equal, then these two are equal. So this is a transitive, so it's going to be written just like this one right here. Transitive property, and we can abbreviate property here, of congruence. And that's that proof. So a lot of your proofs in your homework will be like this, where you're just filling in the blank. They may give you the statement, you got to give the reason. Sometimes they give you the reason, you got to give me the statement. All right, so let's take a look at some other theorems. Some of them have names, some of them do not. This is called the Theorem 2.2 Congruent Supplements Theorem. So if two angles are supplements of the same angle, or of congruent angles, then their two angles are congruent. So if 1 and 3 are supplementary, and 2 and 3 are supplementary, then that means that angle 1 is congruent to angle 2. So if these are supplementary and these are supplementary, then 1 and 2 have to be congruent. For instance, put a number in here. If this is 120, this is going to be 60. Well, if this is still 120, then this has to be 60 in order for these to be supplementary, so therefore these have to be the same value. The next one is the congruence complements theorem. So that means the last one was determining that something added up to 180. Complements mean it's going to add up to the same 90 degrees. So if two angles are complements of the same angle, or congruent angles, then the two angles are congruent. So 1 and 2 are complements, which means 1 and 2 are going to add up to 90. And 2 and 3 are also complements, means they're going to add up to 90. Then that tells us that angle 1 and angle 3 are congruent. So these two are the same. Then we can say that these right here are going to equal each other. The next theorem here, 2.4, is going to be the right angles theorem. So this is all right angles are congruent. Okay, angle 1 and angle 2 are right angles. So if they're right angles, now we can say that angle 1 is congruent to angle 2. They're both equal to 90 degrees, so therefore they're equal. Theorem 2.5. If two angles are congruent and supplementary, then each is a right angle. So if you're going to be congruent and supplementary, then your angles have to be right angles. That's the only way you can be congruent and supplementary. 90 gives us 180. So 1 is congruent to 2. 1 and 2 are supplements. Therefore, angle 1 must equal angle 2, which is equal to 90. All right. What three equations can be used to determine the value of x in the figure below? Choose one and solve for x. So let's look at this together. So if I was going to solve for x here, there's several ways I can do it. We're going to write three equations. The first equation is by using vertical angles. So first one here, I'm going to say that 8x minus 12 is equal to 7x plus 8. Those two angles are congruent. The second method is I can say that these are supplementary. So I can say that 8x minus 12 plus 32 is equal to 180. And so just like these are supplementary, so are these. So the third way would be 7x plus 8 plus 32 is equal to 180. Then it says pick one and solve for x. It doesn't matter which one you choose. So I'm just going to choose the last one. So 8 and 32 give me 40. So 7x plus 40 equals 180. Subtract 40. 7x is equal to 140. Divide by 7. X is equal to 20. Okay, so either way you did this, you're still going to get the same result. Three different ways to work it. It all depends on which way you prefer. So 8x and minus 12 plus 32 is going to be 8x. This will be plus 20 equals 180. Subtract 20. 160 equals 8x divided by 8. And this becomes x equals 20. Over here, I'm going to subtract 7x. 12. Add 12. And now, this gives us x on the left and 20 on the right. So either way you choose is going to be correct. So let's take a look at our last example. Find the value of each variable and the measure of each labeled angle. So we have to find the value of x and y and also figure out what these measures are. Now remember, anytime you have vertical angles, you also have a pair of supplementary angles. So we have these are a linear pair, these are a linear pair, these are a linear pair, and these are a linear pair. So these are vertical. So I want you to see if you can figure out the relationship between your x's and your y's. And there's several ways to do this problem, but I want you to solve for x, find the value of y, and find the measures of all these angles. So pause the video and do this one now. Alright, so this is just one way to set it up. First thing I want to do is I want to recognize my x's. What is the relationship between my x values here? The angles that have just an x in them. And I know the vertical angles, so I know that they are congruent. So I can set them equal to each other and solve for x. So that's my first step. So find x. So I got 14. Now, at this point, you could set up another equation that says that these two are going to add up to equal 180. But to me, I find it easier to go back and plug it in into one of my equations. I picked 3x plus 8. You could have chosen 5x minus 20 because they're both going to be the same. 3 times 14 gives us 42, plus 8 gives us 50. So these two are going to be 50 degrees. So if this is 50 and these are a linear pair, then I can take 180 minus 50 and get 130. So this angle is going to be 130. So I know that whatever 5 times x is plus 4 times y is going to equal 130. So since we know what x is, I'm going to plug 14 in for x. Rewrite this equation, plus 4y is equal to 130. Now remember, I got 130 because I subtracted 180 from minus 50 to get 130. So now I have 70, 5 times 14 is 70, plus 4y equals 130. Subtract the 70 to get 60. Divide by 4 and that gives me 15. So my answers are x is 14, y is 15. These two angles, vertical angles, are 50. And this angle at the bottom here is 30. And so that concludes lesson 2.6 and the conclusion of chapter 2.